This time I want to tell you a little bit about how to do an interview. Sometimes reporters come and call you and want to know something of you, from you, and they want to do an interview with you. And actually that's a very comfortable position because you need not first arouse the interest of the journalist, as we saw last time what is typical. But the journalist knows you already, and he wants to get some information from you, and he's interested in your work. And it's also a good opportunity to tell a reporter about your work. But there could also be some dangers, because you never know what you write afterwards. So you should be cautious in some ways, and I want to give you a few hints what you should do, or what you should pay attention to, and what you should avoid. And in the second part, I want to make some exercise with a few persons of you who would perhaps like to give me a very small interview, and we could practice what to do or what to do not. So let's see. First of all, I want to tell you that the journalist who calls you is not an enemy. He's just a neutral guy at first and wants to know something about your work and is interested in your work, and that's a good position actually. So don't have prejudices against him at first. What is very important, but many people don't do this, is when somebody calls you and he says he's a reporter, and you don't know him, of course, ask for his name and where he's coming from. Never speak to an anonymous person. I often call scientists and I say my name, and I say I'm a journalist, I want to ask you about this and that. And they talk and talk and talk, and that's good for me, but at the end they say, who are you? That's too late. So if somebody calls you whom you don't know, and he says he's a journalist, ask his name and his phone number and write this down, and ask for which newspaper he works, or for which television or radio station. And if you are suspicious about somebody, just say, I'm in a meeting at the moment, I will call you back in a few minutes, and then you look him up in the internet, or you ask your public relations officer about him, so you can be sure which person it is. Sometimes perhaps you wouldn't talk to a journalist from a newspaper which has a, I don't know, political orientation which you don't like, or you know somebody with whom you would not like to talk at all, or things like that. So be cautious in this case. Ask him also for which purpose he needs this information. Ask him whether he wants to write a big story or a feature, or whether he wants to just a little information about something very special, or whether he wants to write about your work or whatever. So you can estimate what you should tell him afterwards. At the beginning of your conversation, ask him which educational background he has, in order to find the right way to explain things to him. Ask him, do you have a scientific background, or are you interested in astronomy, or are you a physicist, or whatever? And it's better to know this first, because you can estimate how much he will understand. I made the experience that nearly every scientist explains you what means 10 to the minus 9 or things like that. But you can be sure that every science writer knows this. You shouldn't explain this.
You don't. It's not your experience.
Also ask him whether he wants, if he says he wants to write something bigger, then ask him whether he wants some written information, or give him some addresses in the internet, that he could, some links that he could look up before, and read something about it before he talks to you. That would be good for him, perhaps. And if he wants to, if he has some time, you could invite him to your lab also. But sometimes people need information very quickly, and they don't have time to come to the lab, of course.
What about, I mean, sometimes reporters are willing or forced to ask questions by email.
Yeah.
Which gives you the opportunity to frame your answers more carefully.
Yeah.
And also enables the reporter to perhaps, go over it and be able to quote more precisely.
Yes, that's true.
Even though most reporters, something you didn't say, will always ask you, even on the telephone. I presume they usually ask, right, whether they're allowed to record conversation, which I always agree to. I don't see any reason why not to.
I think you should agree, because it's better. You can later you can prove what you're saying.
Well, at least you don't have the recording; they have the recording.
Yeah. Yes, he has to prove that. He
But at
said
least,
something.
the worst things are when reporters don't have a recording or anything in writing and get it wrong.
But on the other hand, people don't always speak so properly that you can quote them literally.
Right.
So you always have to do some editing and shortening and things like that.
So, one strategy is to say, maybe the best thing would be for you to email me your questions and I'll answer.
I hate this because it's so dead. You can't respond to the answer and do a second question because you didn't understand part of it and things like that. That's so like a clerk, you say, clerk in an office who says, oh, there's a form and you have to fill it out.
Sorry, but your mic has gone dead.
Oh, it's behind the
Okay, let's see if that works. Thanks.
So I do not like this very much with these things. Okay, when the interview begins, try to confine yourself to the essential facts. Don't tell the whole story, how you have come to this and everything around. He will ask you when he wants to know this. Just ask answer his questions, and when he needs some more information, he will ask you. Because sometimes, especially colleagues from the newspapers, they just need some short information from an expert, and they don't want your whole life. And if you want to give a confidential information or want to show your skepticism about something, you really should know this before. You have to say, I will tell you this only as a background information. You are not allowed to quote me. And then the journalist won't do this. But you should say this before and not afterwards, and not the day afterwards. Just say it before. And never criticize colleagues, because you can be sure that the journalist will quote this. On the other hand, every reporter is glad to get some confidential hints, which he may cite in a special way, encryptedly. He then can write, insiders believe that something happens, or well-informed circles say that, things like this. And that might be very useful for a journalist, because he has no inside knowledge, and he needs someone who has. also provide information only about things that you are concerned with, connected with, and about which you really know. If you are not an expert in something which he asks you, you better say, ask a colleague X, Y, and tell him who knows better. Or you refer him to the public relations department. It's better than to tell him things which are on behalf of right. When an interview will be printed as a question and answer interview in a newspaper, in Germany there's a law which says you have the right to authorize it before. Also, if it's not printed but broadcast, you have the right to do this and you have the right to alter it. Now, Rachel told me that it's not true in America. But I think it's true in Great Britain, for example.
No.
Not?
No.
No?
In fact, I mean, it's so against the culture of reporters in this country.
Yeah.
I mean, except for professional journals like Physics Today or things like that, magazine, no reporter will. I don't know why. I mean, even if they agree that they would write a better article if they passed it by.
No, it's only for interviews, not articles.
Yeah, I'm talking about interviews.
Yeah.
They just won't do it.
Uh-huh.
Right.
Yeah.
I think
I
part
mean,
of
it's
it is.
their ethic. They're independent. That would be.
But they're not independent to write, to quote things which have not been said or not intended.
No, but I mean, certainly in Britain, the point is that they can quote what's been said.
Yeah.
If you have the right to veto it, then you have the right to change your mind afterwards. And if you're not in science so much, but if you're a politician, for sure, they want to catch you out. They want you to say something that you wish you hadn't said. That's the first priority they have. And then they will definitely publish it.
And they do that. I mean, I really love it because I think it's maybe, Rachel, since you've been now inculcated into the culture of yours, you could defend it. But
Well, I mean, I can definitely understand why you would want to see these things before they go into print. I think
I
the
understand why
rationale.
you might want us to see them as well.
I mean, I occasionally will, send paragraphs that to sources just to check or whatever. But I think the idea is that when a reader sees a question and answer, what they're seeing is a representation of the conversation. And if your source goes in afterwards and starts, changing wording, then it's no longer a representation of the conversation.
Well, the representation of the conversation so often actually gets distorted by lack of understanding, and so the corrective. I mean, this culture comes not from science journalists, but from the top of the hierarchy, or the political journalists, and for them it might be very important. But that's where it comes from, but it's going all the way down the chain. And so someone like Rachel, it's sort of you feel uneasy even sending little paragraphs, right?
I make it clear, I don't, but I make it very clear when I send them off that I'm checking for accuracy, and only accuracy. So unless there's something horrendous about the quote.
When you actually quote, do you always have a recording of the thing exactly? So.
It depends. I find that if I have to turn around a story very quickly, I may record an interview, but chances are I won't have time to go back. So I'll just rely on evidence.
And in dealing with science, one can easily make misinterpretations, but not for any bad reason particularly, or anything to do with crimes against humanity or any, just mistakes.
But one thing in science we do is we use words with very technical meanings. And a word that may be interchangeable in English is not interchangeable to scientists. And so, if it's not an exact quote, you may substitute a word that in the English vocabulary is basically equivalent. But then that makes us look like we said something was wrong to our colleagues.
Yeah.
That's an interesting point. Many scientists give interviews because they always think of their colleagues. I will be quoted like this and that, and my colleagues will read this. That's very interesting point for scientists, but it's not interesting for journalists.
Can I say something?
Anyway, we're not going to change the American culture on the country. But it's really interesting that in Germany, it's the other way around.
It's, we have this law, and you have to show the interview to them. He's like a co-author, and his name is written there, and he's a co-author, and he should. Yeah.
Can then the person reject only the entire interview, or can he ask for changes?
He can ask for changes. Of course, he can reject the whole interview. But why did he do the whole work? He wouldn't give an interview then. But it already happened to me that people sometimes, especially politicians, ordered so much that you wouldn't like to print it anymore. So it's his own fault then. He doesn't appear in the newspaper what he wants, of course.
Did you have a long lead time on those things? Because it seems like that would take,
Yes, the time is a difficult point because scientists think in weeks and months and years until they get something new. But we have to work very fast. The newspaper will appear perhaps next day or the magazine next week. So if you want to reread an interview or even an article, then you must be quick and do this in half an hour or so. And otherwise it would be not practical, I think. But
I just wanted to make two comments, actually. I don't think we so much have to worry about other scientists thinking that you said something stupid, like work is energy, or because basically everyone's had that kind of experience or knows someone that has, but there are still other people that you kind of worry about. And last time I was interviewed for something, it's not a science, it's not really science. I specifically said, could I just, then this was not a lead time issue, this was plenty of time, could I just look at it? I'm not asking for veto power, I'm just asking to, if I can correct anything like equations or just, you don't have to take my suggestions, I just want the opportunity to make them. And it was, no, we don't do that, we just don't do it. And so it's clearly a culture, a journalist culture thing, it's not, so you're in two different cultures, right? Because you sometimes interview people here and sometimes there. Are you more comfortable with it because you're used to it in Germany?
We usually don't show the articles to the scientists. They cannot reread the articles we write. Only this question.
Only the quote.
It's an article versus interview, right? It's different.
Only for interviews. And they might ask to check the quotes.
What do you mean? The interview is part of the article? If you write an article and you give a quote.
And you have a quote, you can check this also. Yes. But only the quotes, and only if it's question, answer, then the whole. But often scientists say, could I read the article before you print it? And usually we don't do this because it's our work and we don't want to have other people doing changing anything, just as you wouldn't like me to change your work. But sometimes it's just like if things are very difficult, I'm sometimes quite grateful if people reread it and could tell me some mistakes. But you have to be cautious there because you couldn't change the style, but even sometimes people try to. Because my name is written there as the author and not yours, you just can check whether everything is right.
So I'm just curious. I think one of the main reasons scientists do want to see these articles is for technical inaccuracies, and presumably there's a perception gap here. Probably, I'm curious what fraction, or if you ask a science journalist, how often does it happen that there are technical inaccuracies in something that they write? Would the answer be very different from if you ask the same question to scientists who read these articles? And is there a way to have a consensus on this between the scientists.
Unless it's egregious, people complain. I don't think the journalists have any way of actually measuring their performance that way. I think it's more than they realize. Because scientists, it happens all the time. And people say, oh. And as you say, since it happens so often, people excuse it. But it happens more often than maybe the journalists realize.
But I think you couldn't prevent it when the scientists reread it.
Oh, yes, you can. We all have experience of reading things and catching things.
No, but what is the so what's the perception among the journalists on how often there are technical inaccuracies?
I don't know. What I read is almost right.
The journalists who do this, and this is, again, there's a newspaper and find it extraordinarily valuable. I know for a fact. So, for example, Physics Today, which is does this automatically.
But that's a scientific magazine. So.
But it is a magazine, though. It's not a journal. It's a magazine. It's kind of a coffee table thing, mostly for physicists. But
science.
It's technically not it's not a journalistic outlet because it's part of it's attached with the scientific society, right? It's not independent.
But they employ
it's science.
Yeah.
Yes.
Except science regards itself as an investigator.
That's true.
But so I don't think they do it necessarily. But it's just a matter of culture. The idea that this, you said to him, my name is on it. Believe me, most scientists have no problem showing their paper to everybody before it's published. They show it to the whole world. And people do. And we found that to be a very useful procedure to archive. That's 6 months before it ever gets published.
Yeah.
And things get improved. Nobody objects to it. Because after all, you don't have to accept their suggestions anyway.
Yes, but if you do this with a normal newspaper and everybody looks at it,
everybody looks at it.
Many people look at the article before it's printed. You need not print it anymore because all the others know and it's no use anymore.
No, but you're saying to the few people you're writing or quoting about, there aren't that. I never really understood this.
I'm talking about popular magazines and about newspapers, not the scientific stuff, I think. So it's often our personal view which we show there in a feature, for example. Or you write a portrait about science. You would never show this to him before. He said, oh, that's not me.
So he says that. He says that anyway. He's going to say that afterwards.
Most people
Well, once they have it, it's there. They just shut their mouth. What are they going to do? But I don't understand. So what is the problem? This is to both of you. What is the problem of showing it to people ahead of time? And they might indeed react. You've totally misunderstood the whole point of this, and here's the way I see it.
But he
That's
could have
extra
told me
information
before.
for you. What?
So that's the danger. He should do this before. So it's so important to do the
But that
interview the
wasn't the
right
question. He
way.
should have done it before. But what is the harm to the journalist to get this extra feedback?
Because we might miss our deadlines.
What?
I think, at a very basic level, it's that we might miss our deadlines. Like, we don't have a lot of time to
Well, that's one reason. But I sense more than that. It's as if this diminishes, or maybe the guy would, the person, you're worried that they would try to go above you to the editor or something. I can't see what the harm of getting more information.
Realistically, most of the time, you would send us something, it takes 30 seconds in the email. We would spend 15 minutes reading it and find 2 words to suggest changing, email them to you, and then it would take you 30 seconds to look at those 2 words, decide whether to replace them or not. So, for a newspaper-style article, I don't understand why it's not a time issue. If we can turn it around fast, it's us who spend the time to get it right. And then you go, oh, that's equivalent, sure. Or you know.
That's 1% of the scientists who only need 15 minutes. They need 15 hours usually, and then change 10 sentences.
If you call and ask me to comment on someone else's paper, I need to be prepared. But if you call and talk to me, and then you send me a one-sentence quote from me, I mean, if I'm not in another meeting, I can read that one sentence in 30 seconds.
Besides what that's it, you just said with a deadline. This is going to be, you have any comments, I'd be interested in them, but you have to respond by so-and-so, period. That relieves your deadline problem. I don't get it.
Imagine you make a painting, and you make a portrait of somebody. And then you say, oh, isn't it beautiful? That's the way I see you. Mm-hmm. And then he comes and says, no, that's not right. And you make it this and make it there.
But these aren't matters of artistic. These are matters of fact. It's technical accuracy.
And then you should change it? No, never.
But if it's technically inaccurate, it's not a matter of opinion or perception. It's a matter of, is it correct or not?
Yes, but I'm talking about newspaper things and popular magazine things, not the scientific magazines where
right, but they get the science wrong in these popular venues half the time. There's something wrong. Often it's minor, but why not make it right?
Sorry, I had a comment. So I mean, I might be on the minority here, but isn't technical accuracy is important, but I thought the point of these articles was anyway to convey the excitement. In these popular magazines or newspapers, I mean, technically correct is one aspect of it only, right? And the other aspect is really to convey the excitement. And it's not clear that they conflict, but if they do, then perhaps as a journalist, it's not right to go towards the point that you convey the excitement more than the accuracy.
Yes. I think that we changed quite a lot of things. We don't use technical terms, and we try to simplify things, and
sometimes that leads to mistakes, which can be corrected easily and harm nothing. It just improve the process. As I said, the science writers who do this know that the final product is much better as a description of the science than it was without this interaction. But there's this tension, and whenever I talk to reporters, you get the same kind of answers, very defensive. By the way, it's my impression that this is true of journalism in general. I don't mock journalism, but science is the one area that most of us know quite well and can recognize errors in the newspapers. So we recognize that field. My experience in life is that whenever I know something about
even the names
in the newspaper, they're sort of like they're always like 50 to 75%, well 25% wrong. And whenever I know about it, and which builds up a feeling that, well, probably everything is wrong at that level, except I don't know enough about it.
Yeah, that's why I tried to show you how journalists have to work in the last talk and what are the difficulties.
It's an extremely difficult job, and therefore, the more you get the help of interested parties in being accurate and truthful, the more it helps.
Can I ask one thing?
Yeah.
So the analogy with art, I understand very well. You feel basically that this is your creation and you don't want it to be altered by some other opinion. Then I understand very well, and I understand that this causes like emotional holdback from changing something, which is probably even true for, at least for me, I mean, sometimes of scientific work, that you view it as a creation. But on the other hand, the artist, a true artist, is only to be held against his own inner image after which he creates whatever he creates, or she creates. But I thought always that the purpose of journalism, of the whole news media, is in the end to report what is happening. Meaning there is a requirement to report the truth that is happening.
Depends on whether it's news or it's a feature.
No, I think even news and a feature, both. Both should be true to what they report about. In that respect, when it comes to the scientific contents of what is reported, especially when they relate to simplification of complicated logical chains of arguments, then I think they should be checked, because that is not something that is in the eye of the beholder. It's not art, it's not pure art.
Checking.
Yeah, but I don't think that science writers are always these fools. You show them now. They are well-educated people.
Oh, absolutely.
And they know what is right and wrong in many cases.
But I couldn't write an article about nucleoid DNA, protein, and RNA, whatever this is. I couldn't do it because I'm well-educated and I know.
That's why I want to tell you how to do a good interview, to tell people what is right and what is wrong, so they can write it correctly.
Yeah.
Many of us teach students. We tell them things. Then they take a very simple quiz afterwards. And a large fraction of them get it wrong. Even though they sat through us telling you. And what it shows, what we all know very well, is that people don't always get the message right the first time. So I don't see why I should expect that a journalist who I say something to once over the phone is going to get it right the first time they hear it.
You could check that.
Wait, that's what we're asking to do.
Ask him, did you understand that? Or
That is what.
Try teaching students.
The students will say, yeah, I understood.
Oh, yeah.
Then we test them. And it comes out they try.
No, by the way, I think this analogy with the painting. I mean, I don't think it's the case that scientists don't understand the consideration that you would have about a piece as an artistic creation, because a lot of scientists do spend a lot of energy trying to write about their work well, and they would have sort of the same kind of passion and perspective about how exactly it's written. So it's not an alien concept from the perspective of scientists that you think of it as a work of art. But like he said, you do understand that there are certain criteria it has to meet, such as saying the right thing. Even while over and above whatever factual or scientific content you're trying to communicate, there is a lot more in terms of it being an exercise in communication. I think so. In other words, if you were to sort of interface with a scientist after the piece has been composed, I would expect that most of them would be sensitive to the idea that this is, in some sense, a work of art whose integrity has to be respected.
It's sometimes the case that we have a different point of view. And I experienced that many scientists are afraid of their colleagues. We call this the peer fear. The colleagues perhaps may envy your public influence and fame, and they try to find mistakes in your quotes or in your work, and they tend to bar you from their peer group. And that's, for example, because people want to read it before also, because they want to avoid it. Sometimes.
As an information, how strict are typically the deadlines for scientific articles? Because it's not the latest news from Iraq, I mean, typically. So
it depends on where you work. In newspapers, it's usually in the early afternoons. And
yeah, but how long you know that you have to do an interview for that day? I mean,
if it's for the next day, of course.
But don't you plan it much in advance? Because I mean, it's...
So the question is, if you have a science column in a broadsheet newspaper, is it that only on Tuesday morning you know that the copy for Wednesday print that you have to write an article about exoplanets, or do you know a week and a half in advance? That's the question.
Usually you have a bit longer time, but it depends. The editor will tell you how long you have time. So if something is quite new, you have to write it very fast.
Yeah, okay.
But if something is just a feature about somebody's work...
Because I understand if you have to do it by tomorrow morning because something new came out this afternoon, yes, you don't take time to check back.
Can happen.
But if you know that you have a month...
Yeah, that's different, so you have enough time, of course. But it's not always just a question of time. Okay. But despite all this mistrust you have against I would say confidence pays. One time you give your time to the journalist, and perhaps the next time he could help you to put something right for you in the public opinion. That is a give and take, so I think you shouldn't be too mistrustful. Everybody tries to do his best. So I would ask you whether you have any more comments or questions. Otherwise, I would like to...
A quick question. Do you think scientists as a profession are more or less happy to deal with the media than other professions, so to speak?
I think they hate it.
But do they hate it more or less than other things, right? So, for example, if you talk to lawyers or medics or something, I mean, how do they... Is it the same or...?
I don't know about that. Politicians love it. But, I also know a few scientists who always want to be in the media. They always call you, they have a new plan and things like that. But these are the exceptions, perhaps.
We know them too. Generally, we don't like them.
Are there any more questions or comments? So I would like to do a few very short interviews with volunteers from you. Are there any volunteers? Oh, so many. So perhaps...
Well, I did agree, but I would much prefer someone else to do it.
Go ahead, Mike.
I don't mind. Okay.
Would you
want me to sit here or come over there?
No, because of the microphone, they couldn't hear you on the...
That's fine.
Well, we could have another mic.
No, it's all
No,
right.
they can't come here. I asked them.
So I took the precaution of not preparing for this talk.
That's good, because I just asked you
Just
about...
called me up on the phone.
Yeah. Hello, I'm Brigitte Roethlein. I want to... my editor told me that I should write a story about your workshop. I heard that in the KFP there is currently a workshop about the physics of glasses.
Mm-hmm.
And I wanted to ask you, why are glasses something special?
From the point of view of physics, glasses are special because we don't understand them. And this is different from most of the materials that you see around you, which you're familiar with, like metals and water. In those cases, the basic mechanical properties, let's say of a lump of metal in terms of its elasticity, we know pretty much how to relate that to the microscopic interactions between the atoms in the metal. And similarly, if I have a cup of water, I stir it around, and there's a resistance when I try to flow the water, which is called its viscosity, and we know how to relate the viscosity of water to the microscopic interaction between water molecules. But if you get a piece of glass, fundamentally it's a rigid object. It's like a solid or metal or other kinds of solid matter. We don't really even know why it's solid, and so we're not in a position to calculate any of the properties about it that you'd normally expect to be able to find out easily. Does that answer your question?
Do you mean the normal glass in the window pane?
Window pane glass is an example of glasses. This workshop, however, is actually focused much more widely than that on different types of glass. There's a specific focus of the workshop on metallic glasses, which again is a bit like an ordinary metal where you have the particles in the metal or the atoms are lined up in a nice crystalline lattice. If instead of cooling, if you melt that, so you have a liquid metal, and you cool it very, very quickly, then the particles don't have time to organize into this lattice, but they still freeze. And then that's actually very similar to window glass, but it's obviously its properties quite different because the atoms inside it are a different type.
So you can divide solids into crystallized ones and glasses, or are there others?
Broadly speaking, that's correct. So it's either ordered or it's amorphous. Both can be solid. And the big difficulty for theoretical physics is understanding the solid character of amorphous solids.
And for example, what about plastics?
Well, plastics are interesting. The word plastic, well, plastic means to flow, or if you get...
you know what I mean?
It's the kind of thing to flow.
Yeah.
Okay, so plastics are made of polymers. So there, instead of having individual atoms, for instance, you have long chain molecules. And again, if you go to a high temperature, most plastics, well, thermoplastics so-called, will actually melt and flow. And this is why you can mold plastic. So if you have a plastic bucket, the way you make it is you squeeze molten plastic into a certain shape and mold. Then when you cool it down, it freezes. And again, in most cases, the structure there is not crystalline. The polymers are not occupying a regular lattice. And in fact, that is a type of glass. It's a polymer glass, of which there are many examples as well. There are other plastics where you basically build these chain molecules in situ, as it were, having already created a mold, if you like, with the shape in it. And then that will never melt because it's already all linked up together. But certainly quite a lot of plastics are examples of glasses as well.
People sometimes say that glass is liquid. Is that true?
Well,
at our room temperature, I think, for normal glass.
Well, what people say is if you wait long enough and you go to Chartres Cathedral, you'll see that the windows are thicker at the bottom than at the top, and that's because they've been flowing down under gravity. A lot of people don't believe that explanation.
But you could measure it.
You can measure the thickness, but what's extremely difficult is to measure the flow of window glass. What you can do, though, is if you get your window glass, and if you're a glass blower, you do this all the time, you heat it up. And as you heat it up, it becomes more and more liquid-like. But there's no precise point at which it's correct to say this has changed from being a solid to being a liquid. It's a smooth range of behaviors with ordinary, very runny liquids at one end and completely solid glasses at the other. But just as a function of temperature with window glass, you can span the whole range, which is why a glass blower can make glass into different shapes.
So you don't know whether this window pane is liquid or solid?
I think it's a matter of opinion and therefore definition rather than something that we don't know.
Is there anything new that you could learn about glasses that might help you to invent new materials, for example?
Yes. One of the interesting things about glasses, as I've said, is that they are basically rigid. But especially if you go to these temperatures where they're starting to flow, then the way in which they flow, if you try to change their shape or you apply stress or try to pump them even, can be quite peculiar and characteristic. And if you can understand that better, then you have a better control over the microscopic structure of the glass and the better ability to, for instance, form it into different shapes, but also to create new, possibly better metallic alloys, for instance, or better components for aircraft engines or whatever, by understanding in a way that we don't at present, this intermediate behavior between liquid and solid behavior, which you get in this kind of processing range of temperatures close to what's called this glass transition from liquid to solid.
So you are theoreticians. Could you find out things which you could tell the glass makers then, or the material people they should do?
Well, unlike some areas of theoretical physics, this is one where experiments are absolutely crucial. So this is a theoretical physics workshop, and most of the people here are theoretical physicists, but there are some experimentalists among us. And it's not a field where you can lock yourself in a room with the basic laws of nature and predict what's going to happen. You have to constantly be comparing the theoretical pictures you develop, which often involve models, in other words, descriptions which are not the most fundamental level, but are based on hypotheses which need to be tested. And these, you have to keep going to experiment to test your hypotheses and then to construct models which actually work. And so it's theoretical workshop, but it's not a purely theoretical endeavour in understanding the properties of these materials.
So you brought some results and you want to interpret them here, or
Well,
you go back and will do some experiments?
Well, of course, there are many experimental results in the literature which theorists can see and try to explain, but there are also some experimentalists in the workshop who present their newest results, and these were discussed by the theorists present to see if they can create a theory, or whether that challenges the models that they have, and they have to go and think again about how they're describing the flow of the materials.
Mm-hmm. Last question. We have heard quite a lot about metallic glasses in a recent time. They should be a very intelligent material, very new, and what could you say to this?
Intelligent material?
Yeah. And
well, there are technical ways in which they should perform better than ordinary metals for certain kinds of application, but a lot of these possible utilities for those materials are currently blocked because of this problem of not understanding the flow behavior well enough. So, for instance, metallic glasses can often fail in ways which are different from ordinary metals. If you exert too high stress, there's certain ways in which they can fracture or break, which obviously is very dangerous if you're trying to build aeroplanes out of them or whatever. And so you really need to understand that type of behavior, and that is part of what we're struggling with at this work.
But what would be the advances of metallic glasses?
Compared to ordinary metals?
Yeah.
Good question. You exhausted my ability to bluff. I don't actually work on metallic glasses at all. But that is what the workshop's about, so I can't learn hardly of that. But I've told you everything I know about metallic glasses.
Thank you very much. If you would have to write a story about this now, perhaps you can imagine that some questions are still open, and you would have to talk a long time, of course, to cover all the questions. But what do you think? Do you think?
What do you think? So I think the point actually, in a sense, I was thinking that we'd be interested in what the journalists think, because in some sense what we think, you're telling us, is what we think is not so relevant in a sense, right?
Well, in the first few sentences I had the impression that you should have asked me before what I know already, because you talked about water and things which are very common, and as a physicist I would have known this already. Perhaps you could have explained on a bit higher level, and I could have asked you faster other questions. And I didn't really understand what is really new. So if I should write a story about it now, I just could write, they have a workshop there and they have some theoretical problems, and there's something very special about glasses and you don't understand it really. But nothing else really. But perhaps because I asked
the
wrong question.
So no.
Maybe he didn't want you to write a story. Maybe he didn't want. Did you want her to write a story?
I hadn't thought about that. But you see, so if you'd actually asked me about my specialist subject, I'd have had my particular kind of in my head sales pitch press release, which opens all of my grant proposals, ready for you. But if you asked me about the program, I was telling you, which is fine. But if you'd asked some of the other participants of that program, they probably could have come up with the kind of the big issue things that you probably wanted to hear.
But the interesting thing I would say, watching you do it, is I will give my personal view, and you see everyone agrees. If you asked us if we think he answered your questions, I would say yes. I would say he answered all of your questions. At no point do you say, what is new? And you go, oh, I've got stumped there, I don't know. But at the end you ran out of steam, we'd be being honest. But we would think he answered all your questions. Yet you tell us, it's interesting, right? Because that's why I asked you what you thought. It's different from what we thought. I would say he did a pretty good job.
So the point here is that Brigitte was thinking in the back of her head all the time, and only asked it at the end of the interview, what is known? Where is the story? which you're never going to ask directly, and wasn't answered indirectly.
I think you would ask it directly, though. I think you would say, like, what do you
Well, she
think?
did at the end.
Yeah. I mean,
No, actually, she asked prior to that. She asked what was new about them as material, and that was a science question which floored me slightly because I don't know. In terms of, when you ask what's new, you're actually asking that about, but by that stage, metallic glasses, which is quite a specialist question, and that's why I gave up at that point.
That was the only thing I knew.
Well, indeed, fine. But if you ask me that about the kind of stuff I normally work on, of course I don't be able to tell you. But there is this thing which is, again, slightly the difference between scientists and politicians, for instance. So the question is, are you answering the questions as best you can, or are you using the questions as an opportunity of saying what you've decided already you wish to be putting in the public domain?
And I have heard people advise, science journalists advise as scientists to do the latter. In other words, you ask me a question, but I give you the answer that I know I want to give you, in a sense, right? But that may not be a crazy thing. I had that once with a Radio 4 interview. We were talking about merging neutron stars to make gold in the universe, so nuclear synthesis. And it's actually a World Service journalist, got it completely wrong. She'd got a very quick brief. It's on about how you find gold. And she looks at how you find gold, like in rock and stuff. I know less about that than this gentleman knows about the subject of his conference. And so you, at that moment, you could either say, well, actually, you've got it completely wrong. You say, well, that's very interesting, but actually, we're looking in the whole universe. And then you can just carry on, which is what I did, fortunately. And I think that's an important point, actually, that in some sense for us to think about what we want to say beforehand is the message I take away from this perfect example.
I think in radio interviews that makes a lot of sense.
Oh, absolutely.
Like, if you're on the phone, though, doing a one-on-one interview with someone, sometimes, because we work so quickly, it's really helpful to just address the question at hand or whatever, so we can just sort of go back and forth quickly.
But a question to you, then, to follow on from that, is someone calls up, cold call, we're sitting in the office, we're busy, we get a call from a journalist, they want to talk about something, right? They're calling you in this office now, they want to talk about the conference. How bad is it for us to say, I'm busy right now, can you call me back in half an hour? Is that going to weaken our position, or are they always going to call back?
Depending on, probably fine, yeah. It depends on our deadlines, but yeah. Because
my point then is that gives you then 30 minutes to think, okay, what are the 5 things I want them to know about this? Mm-hmm. You can go to next door and find out a bit more about it.
Exactly. Which I did deliberately not do.
Yeah. But it's a real question.
The other thing it gives you time to do is to think of, which is advice I would give, is to think of a quotable sentence.
Yes, indeed.
And that's something I wanted to touch on, because Brigitte is saying, I ask the journalist what their background is, where they're coming from. I try to disguise that as much as possible. I deliberately don't tell people when I call them up that I have a physics background. And if they ask me, I'll say yes, but pretend like I don't,
But you would tell them you write for New Scientist, for example.
Yeah. And most New Scientist journalists have science backgrounds of some sort. But I find, there are 2 points to an interview. One of them is to get information so you can write your story and make it as accurate as possible. And the other is to get quotes. And they're sort of in conflict, You can have a nice, good technical discussion with the source, and that's very useful, but you don't get good quotes out. Because all of a sudden you're talking technical terms and acronyms and things like that. So there's a balancing act there, and it's definitely good to keep in mind, that journalists need sort of both. So good quotes are always useful.
But only if you have very little time, you should say before what you know already, because you will tell you everything about the fundamentals, and perhaps you don't have time for this. But that's a good strategy, what you do.
Do you find it helps if the person knows the magazine or newspaper you're writing for, especially as international journalists? So if you call up and you say you work for a German magazine that we've never seen, maybe that's not so easy. Whereas if we've all at least looked a little bit, hopefully, at New Scientist, and we've got some sense of the sorts of things they write about and how they do it.
You should ask what sort of magazine.
No, but my point was that does it help that people read them, right? So if you call up and they know what they're writing for, whereas in an international setting, we wouldn't know whether a magazine in Germany was something we buy at the supermarket checkout, or whether it's like a New Scientist, right?
Yeah, I think that would definitely be helpful. Who's your audience?
Okay, second interview. Do we still have time? Would like to? No?
If no one else would volunteer, I think I already said I'd do it. So.
Sure. This is the astronomers. Announced that they had found, I just come to near because of the microphone, that they had found some exoplanets which orbit the stars the reverse way when the stars rotate. How could this happen?
So indeed, recently there were observations reported where the star's spin axis is not aligned with the orbital angular momentum of the planet. And
vice versa.
Either very misaligned or perhaps even pointing roughly in opposite directions. Maybe not exactly opposite, but at a large angle, like an obtuse triangle.
Okay.
And so those observations are very interesting because early on we might have thought that all planetary systems were like our own solar system, in which the planets all orbit in the same direction as the star spins and actually are relatively closely aligned to within maybe 5-10 degrees. Mm-hmm. So these observations are very different from the solar system, which until very recently was all we had to go on. And so we're now at the point where we're able to study other planetary systems and make observations that we've never been able to make for any other system, and we find out, well, they're not all exactly like our own. For many years, our theories were developed in a microcosm of knowing only about our own solar system. Yeah. So we could explain it very well. Mm-hmm. But now we have these other systems, and we haven't as long to think about them. Uh-huh. So the interesting thing is that the mechanisms that were invoked to explain the solar system aren't entirely adequate to explain these new planetary systems. Now, astronomers aren't entirely in the dark. We've been trying to explain other properties of these extrasolar planetary systems. And in the process, we developed theories that might explain other properties like their separations, distance between the star and the sun, or the elongated nature of their orbits, being highly elliptical rather than nearly circular. And some of those theories also predict that some of the planets will be misaligned between their orbital path and the star's spin. So we have some ideas, but we don't have an answer for you.
But what are these ideas? How could it happen?
So if everything were confined to the surface of a sheet of paper, then everything would stay on that surface of the sheet of paper. And there's sort of no way to break the symmetry of everything being confined in just a simple plane.
Am I right when I think first it's a disk, and then there's a star in the middle, and the disk is rotating?
So you're thinking of planet formation, so the way these systems formed. Then we believe they formed from a star with material that created from far away, originally not in a disk, but then collisions, dissipation, caused it to form a relatively flat object, maybe not perfectly planar.
Okay. And from this, the planets formed.
And the planets have formed out of that disk. Okay. But what we observe today, the disk is gone. And so the planets we see today, we just see the star and the planets, or we really just see the star and infer the presence of the planets. And so in those cases, we hypothesized that something had to allow the object to come out of the plane. Yeah. And so there are different possibilities. One is that the planet may have other bodies, maybe a massive planet further away, or a massive star even further away, that is not orbiting the same plane as the planet. And by breaking that symmetry using two orbital planes, well, now it makes sense how the interactions between the planet and another star or a distant planet could cause their orbits to change their orientations.
What interaction?
Gravity. Oh. So all the interesting physics governing the orbit is basically governed by gravity.
I see.
What we see is light.
So I could say it pulled it out from this plane.
I might try to rephrase that. Instead of thinking of it as pulling out of a plane, as the different bodies interacting, so their gravitational interaction causes a torque that changes the direction of rotation. So if you think of riding a bicycle, you try to sit on that bicycle while not going anywhere, you would promptly fall over. Yeah. But if you're pedaling your bicycle fairly fast, then the angular momentum in your wheels makes it harder to push you over. Yeah. And so just like the bicycle wheel is spinning around the planet, spinning around the star, and so there has to be a torque, a force applied in order to tilt that. And so it's the gravitation provides the torque to those two paths.
But it could be a pull or
well, when you say pull, I think of a rope where I'm pulling something this way. Right? But it's not so much pulling it up, but rather having the gravity cause a much more gradual change in the orbital path over at least tens of thousands, if not billions of years. Mm-hmm. So it's not me directly pulling on the planet itself, but rather the interaction on both the planet and the star that it's orbiting. Mm-hmm.
Did this happen to Pluto and his moon?
That's an interesting question. So in the solar system, the planets are nearly coplanar, as I mentioned. Some of them do have some modest inclinations, Pluto, for example. That's believed to be due to interaction with Neptune. So again, it's gravity that's causing the interaction. But the details of how that occurs is very different. So Neptune's orbit appears to have moved outwards with time by several times the distance between the Earth and the Sun. And in the process, there were resonances. So these times when the orbital period of Neptune was roughly comparable to a nice simple ratio to the orbital period of Pluto. And that allowed a particular type of gravitational interaction which is sort of qualitatively different than the types of interactions we're talking about to explain these other systems. But the overall effect of gravity is common to both.
It was also gravity.
Yes.
And is it stable now?
Are you asking about Pluto or are you asking about the other planets?
Pluto and...
Okay. Well, I do know what you mean by stable. The outer solar system actually it's not clear whether it has regular motion or is chaotic. And that's because we don't know the masses and positions of the planets precisely enough. And so if you want to know what's going to happen in 10,000 years, no problem. If you want to know what's going to happen in 5 billion years, well, then we have a bit of a problem.
So it could happen that it tilted still more?
Well, Pluto is not going to flip its orbit all the way over. So that because of the current orbits, the inclination of Pluto may become excited more. If the giant planets, if Jupiter, Saturn, Uranus, and Neptune had some chaotic evolution that caused one of them to get thrown out of the solar system and pass by Pluto, then crazy things could happen. But that's certainly not in the cards anytime soon. And it's sort of very different from these other planetary systems where there may have been these sorts of violent interactions that have not happened recently within the solar system.
Okay. Last question. Does this happen often?
So now you're getting to the real point of the recent press announcement. And that is, before we knew of our solar system, and in the last year or so we've learned a few other systems that were either similar to our solar system or one or two that were different. The interesting thing about this recent report was that it says that there are several systems that are highly inclined, and they suggest that it may be that these are actually more common than planetary systems like our own solar system. I think that claim will be borne out by more observations. It needs to be tested by observing more systems, observing them more precisely. But there's hints that based on a small sample of observations that are reported in this particular press release.
Okay. Thank you.
Sure.
So this time it was easier because I had a special question and you could explain this. And I think I could understand it and perhaps I could write it without big mistakes. What you forgot, of course, was to ask my name. Okay. Any comments? Want to leave already?
I mean, to me, without being critical, I thought your first answer was very long, almost as if you did have your pre-prepared manifesto that you wished to deliver. Did you find you thought that was fine?
No.
The first answer, which was quite a lengthy answer and seemed to be kind of delivering a pre-prepared story.
Yes,
you were happy with that?
Because it compared the solar system with other systems, and perhaps that wasn't so clear before. Okay,
so basically that answer, which was basically sort of doing some of your work for you, was welcome.
Yes.
Yeah.
Because, should we finish now, or I have a
Rachel, did you?
victim?
Rachel wants to add some.
So please.
Yeah, I mean, I thought that was fine, actually. I got a little bit bogged down with the torque discussion. I think that was like a good point to make, that this wasn't, but I was completely lost as to what point you're trying to make. So maybe, gravitational attractions are gravitational attractions. So I wasn't sure whether this was a crucial distinction that I needed to make in this.
Or was it a nuanced attempt to distinguish between the effect of angular and linear momentum, right?
Or was it an attempt to not be misquoted? I felt like you were worried that something was going to appear in the article that sounded completely wrong.
So it wasn't so much that I was worried of being misquoted as it was that from the way the question was phrased, My guess was that you were thinking about it in a way that I wouldn't try to describe it to a student if I were trying to explain to you what is going on. Words like pull have kind of connotations that suggested to me you're thinking of it differently than I was trying to describe it.
You couldn't write in a newspaper gravitation into
But no, I understand that. You're going to say that, but I was trying to help you see the difference between the two, and maybe I failed.
I like the bicycle thing. I think the point is really, in a sense, in broad terms, is what you were trying to say is that the perturbation, the change of the orbit is over many orbits. It's not like two planets get close and instantly are pulled apart, right? And I thought the bicycle thing was good. The question I had, though, for the journalists about this, which occurred to me while Eric was talking, is the following, which I never thought about before. You're on the phone, so this is a telephone interview, so you're not interviewing in person. Is it at all credible or just a crazy idea to point journalists to particular graphics, maybe a video or something? Because in this case, there could be, for example, animations that show this happening. Even if you know that's not useful for them writing the article, because you can't put a video in New Scientist, at least not in the print edition. But at least if you believe reasonably that the journalist will understand something from it. So say, for example, you have a video of a planetary system being perturbed that you used in a public outreach talk, for example. So the journalist could credibly understand that. Is it at all credible to point them to that, even in real time on the phone, right?
Oh, yeah. I mean, that's totally welcome. And I've gone through paper figures with people on the phone before.
Okay.
So, yeah, that's definitely.
The other question is a sort of small question. If you have a one-to-one interview, if you start writing things on pieces of paper or go to the chalkboard, is that a good thing or a bad thing?
Skype.
Wait, if you have like in the same room?
Yeah, sorry, in the same room, yeah.
Yeah, I mean that's fine. I find like when I do interviews with people like in person and they go to a chalkboard, it becomes a much longer interview. I try to sort of sit them back down again as quickly as possible because it's very easy to get sort of to keep going, you know.
I had another question, sorry, very quickly. I'm just curious to give us an insight as the two journalists here. So imagine either of these two scenarios, you're writing this for a broadsheet newspaper or the Economist science section or something. You've got a day or two to write this. How much time? The interview's just finished literally 5 minutes ago. Is the article going to be written in 15 minutes, an hour, 15 minutes? How long are you going to spend on this article? 150-word piece. How long are you going to spend on it?
150-word piece.
Well, it's what I'm guessing, but that's sort of typical short thing in New Science. The Economist has 4 articles in the science section, right, one side. So it's going to be that sort of order, I would guess.
I would need 3 to 4 hours.
So 3 to 4 hours.
Yeah, I mean, it sort of depends. Like sometimes
perhaps you're shorter because you're in this material.
Yeah.
You're familiar with things.
I mean, something like this, I could probably. It really sort of depends on the circumstances. Like sometimes interviews start your reporting process, you know, and then you're digging through a bunch of stuff, sort of rummaging through to get other details you need. And sometimes it sort of ends your reporting process. So like once all the reporting is done, whatever it is, like maybe a couple of hours, maybe 3. Yeah. I mean, chances are too, like you're not going to be interviewing just one person for a story, so.
Do you tend to use, so say you've talked to Eric about this exoplanets and then you call up, I don't know, someone else. Are you going to use what he has said to other people, or do you tend not to do that?
Like, well, Eric Ford told me X.
Well, no, but even without citing him as a person directly, you say, is this like the bicycle wheel going round or something? Right?
Yeah, I mean, you know,
tend
just
to
sort of
use
that as a prompt.
Yeah.
My understanding is this, is that correct?
Or here it's like Pluto or something.
Yeah.
You wouldn't say Eric has said.
No, that's not what I was
People do that too. They say, I just interviewed so-and-so and they said this. Do you agree? I get it all the time.
Yeah, okay. So, what do you think? Should we stop now or do an interview?
I'm ready to stop.
I think. Okay.